Hello, everyone. My name is Karel Doosterlink. Last year, I was also following the I course. So for me, it's very fun now that I get to give a demo in this course. This demo is a result of my 6-week internship at Waylay IO over this summer vacation. So my work has been over IoT automation using GPT-3. So automation together with text and speech processing is actually very valuable. There is a lot of value in automation, but currently you need to be able to write code in order to do good automation. Luckily, there are companies like Waylay which are making automation more accessible to everybody via a low-code or a no-code approach.
Onze software laat eigenlijk toe om op heel grote schaal heel veel data te gaan processen. We bereiken daaruit bepaalde inzichten, maar dan zijn er uiteindelijk nog altijd mensen nodig om die inzichten om te zetten in daden.
Oké, dus mensen moeten geen schrik hebben om hun job te verliezen?
Absoluut niet.
Oké. Op welke manier kunnen bedrijven jullie technologie toepassen?
Wel, Waylay's technologie wordt vrij breed ingezet. Waylay werkt vaak samen met bouwers van apparaten en machines. En dat gaat vrij breed, dat gaat van HVAC tot en met industriële machines, kleppen, pompen en lagers. En anderzijds wordt onze technologie ook ingezet in de markt van de slimme gebouwen, om die op een energie-efficiënte en veilige manier te kunnen gebruiken.
The example that we show here is an example from our drag-and-drop editor in the Waylay development console. And what it shows is a rule in which we have some sensor data entering on the left-hand side. You see the data processed through a number of nodes, and then it kind of enters this first red rectangle box where an analytics algorithm is being applied. And here we use as a serving framework Kubeflow. But as you see on the icons on the right-hand side, you can kind of replace this Kubeflow icon with any popular machine learning development framework, whether it be TensorFlow, Azure ML, or SageMaker. We can kind of embed that in your automation rule. And then moving on further to the right-hand side, what you see is that we do not automatically convert any anomaly detected by this algorithm into a notification, or in this case, a work order within Salesforce, but rather we apply some additional heuristics in order to avoid too many false positives. And then finally, on the right-hand side, you see the integration with IT, in this case, Salesforce. But again, you could imagine that, you know, if you're not using Salesforce, but another line of business application to kind of report issues, this is a flexible integration mechanism, and we could support those as well. So in this one example, we have a combination of automation integration between IoT and IT. We embed an analytics algorithm to make it operational. And what we typically see with our customers, that domain experts are capable of building these rules without needing the support of R&D. So we kind of decouple it from an R&D cycle.
But to take it even one step further, it would be nice if you would just be able to describe what we want to happen and have a machine learning model really process that speech, process that text, and output maybe code that can be used to automate it, or in this case, output a data structure which the Waylay system can understand, but you can really think about it as it's just outputting Python codes that you can then run on a server, and that does the automation task. So this is really difficult because our input is noisy. There can be spelling errors in our text, or there can be background noise in our recording. There's also many different ways to basically say the same thing. So it's also very, very ambiguous. There's also almost no data. So Waylay is focusing on IoT automation. There is no publicly available data set of people describing IoT problems and the corresponding code you need to solve it. And lastly, we want the system to be really flexible and to adapt to new capabilities. So if there is for example, a new machine in the factory, and you want to be able to automate that machine over voice, you don't want to retrain an entire machine learning model. You just want to be able to expose the capabilities of that machine and have it working, out of the box seamlessly. if you consider these three free flow, so natural pieces of language, so please SMS Verzellen, if the sun is shining in Ghent, tell him hello, or say hello to Verzellen via SMS, only do this if it is nice weather in Ghent, or when it is sunny in Ghent, text a hello message to Verzellen. Now, to us humans, it's very intuitive that these things mean the same thing, and you could easily code this up in Python. However, mapping these things, these individual pieces of text to a piece of code via a machine learning model is really very difficult, especially given that there is not a lot of data there. So we need to be creative, and we can kind of cheat a little bit. Instead of directly mapping these things, we map them to an intermediate representation. So consider, for example, this intermediate piece of text. If the weather in Ghent equals sunny, then send SMS to Verzellen message hello. This is something you can read and you can understand, and you know this means exactly what these other pieces of text are trying to tell you. But this piece of text is also easily machine readable. It's very structured, which means you can then have a just not a neural base, but just a rule-based parser that can process this and can translate this into the inputs the Waylay platform needs to get this automation rule up and running. So now we have redefined our problem, and we have shifted our attention. Instead of translating the text to code, we're now translating text to text. And this is a bit less difficult. However, it is still difficult. And luckily, I did this internship this summer vacation and not 2 summers ago, because this summer vacation, I had access to GPT-3. So GPT-3 is a very, very large, it was for a long time the largest neural network. Now it isn't anymore. It has 175 billion parameters, which is not something you can host yourself on your laptop, trust me. Not something even many companies can host. This is behind an API, and you use it via the API, so you don't need to host the model yourself. This model has been trained on language all over the internet, and it's predicted, given a sentence, it's trained, given a sentence to predict the next word. And we can use it in that way to translate it from the gray text, so the unstructured text, to the structured text. And once we can do this, then our problem is basically solved. Now, how do we do this? Let's say we give GPT-3 a piece of text, the capital of Belgium is, and we ask it to predict the following 3 words. There is, a probability it will output a nice city. But let's say we want the output Brussels. We want to use it for some reason as a kind of to just answer these kinds of questions. Well, we can kind of trick it to do what we want by giving it an example. And this is called prompt engineering. So we are engineering how we prompt the model. So if we instead of giving it a small string, the capital of Belgium is, we give it a bigger string, which includes a couple of examples. So the capital of France is Paris, the capital of Belgium is, and then if it reads that entire text, it picks up upon this pattern where you have France and Paris, and now it knows to say Belgium and Brussels instead of Belgium and a nice city. And this is actually, if you think about it, really remarkable, because we are influencing the behavior of our model at test time. Typically, you are doing fine tuning, or typically you are training a model to get different behavior, but now you include different examples to get different behavior. This allows you to very easily prototype some very complex behavior, because you don't need to do any training, and with 5 to 10 examples, you can teach the model to really do a lot of things. So that's why we really needed GPT-3 in this for this project, because we didn't have much data, and this only needs a couple of examples, and we don't need to do any training, so it can just work on the fly with new data, really efficient. So now I'm going to show a demo how this is actually working. So here, here is a small demo application I made, and there's currently 4 examples in our database, which is not a lot to do machine learning. These 4 examples, so they all consist of a natural piece of text and then the corresponding structured text. So this is just to give the model a flavor of what am I expecting. So, and all these 4 examples, they relate to sending an SMS based on a weather condition. So, okay, let's see how what the model can learn to parse given only these 4 examples. So here I can input, I will split my screen because I have some examples prepared. Here I can input just some natural text. Then we will see, given the examples that are in the database, what GPT thinks the structured representations. So we're going to start with something really easy. If the weather in Ghent is raining, send Thomas an SMS with message, oh no, rain. This is trivial. To parse this, all your ingredients are there. This is the piece of text that GPT-3 sees. So here we have our piece of text that we now want to translate, but I added also all the other 4 examples. So GPT-3 just reads this and then tries to predict the next words. And the next words are, they are correct. If the weather state in Ghent equals rain, then send SMS to Thomas, message, oh no, rain. Easy, right? Nothing spectacular. So we're going to try to make it a bit more difficult. So send David something about unicorns via SMS if the weather is sunny. And I'm talking about the weather in San Francisco. So this is already much more difficult because we don't have an actual message. We just say, tell him something about unicorns. It's not an actual message. And this weather, it needs to understand both of these sentences to know that the weather in the first sentence that needs to be sunny is referring to the weather in the city San Francisco. So if we submit this, we see that this model, based on only 4 examples, again, quite remarkable, is able to correctly predict if the weather state in San Francisco equals sunny, then send SMS to David message, and then it just decided something about unicorns to say unicorns are real. So that's really, if you think about NLP automation, this is really valuable because somebody that will use a system over voice, he or she will never, sometimes will just speak like a human does, right? Or speak like here in multiple sentences or not give an exact message. And you need a very robust model that has a lot of knowledge about the world to interpret these imperfect human statements and to translate this in the structured format. So here, if you, for example, replace San Francisco with the capital of California, we will also see indeed that instead of saying weather state in capital of California, which you would do if you would just like have a rule-based parsing and you split on the in and you check this, you will have the weather state in and a capital in California, but that's obviously not all you want. Because all the other examples have cities like Ghent and Moscow and Paris and Brussels, it knows to expect a city and it knows that San Francisco is the capital of California with high probability. Well, it doesn't know this, but like many machine learning models don't know per se what they are doing, but this is the most likely continuation. So for example, this is something I find quite remarkable. So I'm now going to give it something it hasn't ever seen before. I say on Monday, text Sam, good morning. And all the examples are relating to if the weather state equals something. So if I submit this, you will see an error message, but that is actually not because of an error of GPT-3. So what GPT-3 does, it says, and it just thinks this is the most probable continuation. If the date equals Monday, then send SMS to some message, good morning. And this makes sense. The reason why it is failing is because I, in my backend, haven't told the parser, once it gets this message, how to interpret this date. But that's the beauty here. The model, based on knowing that a weather state can equal something, it knows that a date can equal Monday. And now I should just add a tiny piece of code to my parser. And now I can start working with time conditions, even though there wasn't even a single time condition based rule in the data set. So you can imagine that this really becomes very flexible, and you can deploy this based on only 5 data examples, have very good performance in terms of your amount of data. And then while the customer is using this, you gather more examples, you feed them in the database, and without retraining, your model becomes better and better and better. So that's really a kind of paradigm shift in deep learning, because we're not even hosting the model ourselves. We're just creating one big string, one big input via prompt engineering with some relevant examples. And GPT-3, which has been generically trained to continue any text, becomes really good at doing our problem. So, I mean, 2 years ago, this would have taken me, I think, way more than a 6-week internship. And yeah, it can do fun stuff. So if you say, if the day is Monday, then text Sam an emoji. Okay, yeah, it knows what an emoji is. So a cactus emoji. So there is a lot of knowledge about language just baked into this model. And just by asking the right questions, by engineering this prompt, you can trick this very, very strong model into doing a complex task for you relatively easily. So recently, the GPT-3 API also became public. So I would advise you really to sign up and just to play with it, because you can really get some very, very fun performance out of this model. So this was what I was working on at Waylay. I thought it was really fun to be able to explore technology which was really cutting edge. I won't be able to, when you see this recording, I won't be able to actually be in the class because I'm on a 9-hour time difference now. But if you have any questions specifically about the technology used or the internship, you can definitely try to contact me via Twitter or LinkedIn. And now Thomas and Jano will be showing you how this technology got embedded in the Waylay platform.
Okay, I'll show you what we've done with the prototype of Karel. Our example of the weather rules that we see everywhere popping up is implemented like this. These are the prompts that have been engineered for the weather example, where some example messages are converted as examples to the canonical format, which is actually the DSL or the language, the domain-specific language that the rest of the parser looks into to generate fragments of Waylay rules. And so, of course, what you don't see in this overview is how these sentences then are converted and matched onto fragments of rules and stitched together. But there are a few built-in rules that say, okay, if you have above, then we do a comparison. If we have an if, then we do a triggering relation. If we have an equals, then we do an equality check. These are a few of the rules that are built into the parser. So if you take this example, for instance, and we say if the weather is sunny, of course, if we generate that, because it's an example, it's just takes the parsed message we have, put as an example, and this is parsed to a simple Waylay graph that has a sensor that checks the weather, then checks whether the condition is sunny, and then sends an SMS if that is true. There is one rule that I want, or one thing that I want to show. Maybe I'll go back to the default rules, but because if the weather in Paris is the same as the weather in Brussels, for instance, sent, clicked. So then, for instance, you see more of the parsing framework working, saying, okay, I have 2 observations to make. I have to wait until they both are collected. Then I can do the equality comparison between them and trigger the rules. So these are things that are built into the system, and of course depend on the fact that those messages can be converted to these kind of canonical expressions.
Like some sort of feedback. So, for example, if the canonical representation is incorrect, that you say, okay, this is how it should be, and then add that corrected to the rule base. So the next time that it's called, it should be correct actually.
Yeah, we had a feature plan to record every invocation of the rule base, even if it fails to maybe able to correct those things. But for instance, an example of the demo that we just had when we used the Dutch translation, and we said is wanneer het mooi weer is. So that got translated to when the weather is nice. But nice is not a keyword that the weather plugin has. So because it needs to be sunny. Well, yeah, okay. So and then you indeed can ask NLP to say, okay, I have either mooi weer or nice. Which of the known keywords is best mapped onto that? This screen, okay. So this is for the weather plugin, which we have a configuration in the generators. It's called visitables, but I'm planning to rename the generators, where you give the pattern in the canonical representation that this generator should latch on, and if it's latched on, in this case this is a Waylay plug configuration. Then it fetches the get current weather plug, which has a more full representation in our plug database, which is an existing system, and says, okay, to configure this plug, I need to know 2 data elements. I need a key, but this key comes from our system, and this is a well-known place in our system, and this is fault. And we need a city to know the location, and this comes from the canonical input, namely this keyword location. And the output is the feature keywords of if we ask for the weather condition, then it's canonical condition. If we ask for the weather temperature, then it will be temperature. So this is and the trigger state that will trigger the completion of this observation will be the status collected.
Okay, so let me just say that here in the meeting with us, Jano is present, and if you will have some questions about this platform, you can also ask questions or put them in the chat. I would also like first to show one other part. So this was the demo about the platform, but there is also a nice, at least I find this nice part, and that, well, Karel and collaborators in the company were willing to share with us some things during the development phase, where you can see also, okay, what can sometimes go wrong or what can be interesting. So let me also show you that. Small video, it's very short.
now it's time to have some fun with this. So I think if it is snowing in Moscow, tell Gilles a joke via SMS. It's running. Yeah, so the problem now is it outputted a too long joke, which my model can't handle. It says something like a snowman walks into a bar and says, I like a beer. Okay.
I have a question.
Sure.
Is there questions? And yeah, is there anything specific in or where is the language encoded? If you would have pre-filled your rules actually with Dutch sentences, would it have worked?
Well, so where is it encoded? The language, the model is just trained on English. However, it is they're working on making multilingual models out of this. So trained on a lot of languages at the same time. And actually these models, they have actually just read so much of the internet that also some Dutch and some French sentences crept in. So if you ask it, please translate the following sentence to Dutch, and you give it an English sentence, sometimes it just starts outputting the Dutch sentence, while it was not specifically trained to do that. You will see my excitement or disappointment live, front row.
Yeah, okay.
I don't think this should work. Again, it has read a lot of data. So als het weer mooi is in Parijs, stuur Zillen een bericht via SMS, submit. Fuck me. If weather status in Paris equals sunny, then send SMS to Velen message the weather is sunny. Mooi is in Parijs en de vochtigheid boven 80 is. Fuck. Yeah, it does it. Yeah, the thing is, they just basically downloaded the entire internet and just trained it on it. So it has also a lot of Dutch. This is also the first time I tried this, but again, to show how powerful this technique is, and maybe also how scary. I don't know, you decide.
It's scary, yeah?
Well, the conclusion was the technology can be scary, but in continuation with this,